You can change it. All right. So this is worksheet 9, rational functions. This lesson goes long, so we're going to try to go quickly. A rational function means that we have some kind of polynomial in the numerator, like this, and we have some kind of polynomial in the denominator, like this. Okay? We have to try to graph that. Do you remember doing these last year? They have asymptotes. Okay? They can also have holes. All right, so the notes actually say the numerator is the function a of x and the denominator is the function b of x. On the green sheet, I think they're called p and q, but it really doesn't matter, okay? Just keep straight which one's the numerator and the denominator, and it's on your sheet. What is the only restriction we worry about for domain? There's not going to be any square roots because these are polynomials. Right, the denominator cannot equal 0, okay? So the denominator cannot equal 0. And you want to do that before you do any simplifying. You can factor first, but you don't want to cancel any factors out or divide any factors out before you do the domain. Everybody okay? Asymptotes, just really quickly, vertical asymptotes, the graph can never cross, but horizontal asymptotes are just end behavior approaches this line. It can actually cross a horizontal asymptote. Okay, so if we have, this graph does not, the one they're shown here, but we will have a graph later today where it crosses the horizontal asymptote and then it just stays barely below it. Okay, so it is possible to cross a horizontal asymptote but never a vertical asymptote. All right, this is called a hyperbola, this shape. It's the parent function. Do you remember this guy? X can't be 0. And because this can never be 0, we can never get the whole thing to equal 0. So it had two asymptotes, horizontal and vertical. All right, this is really the green sheet. Okay, what's on the green sheet? But this is off the notes in front of you. There's a lot of information in this slide. It says, when you have no common factors, after you've reduced this if you can, then the degree of the numerator and the degree of the denominator will determine your end behavior, or the bottom heavy, top heavy, equal weight. Are those words sounding familiar from last year? Okay, everybody did this. If you had regular Algebra 2, you didn't do a lot of graphing of these, but you still had to find the asymptotes, okay, the equations. All right, before you would actually reduce, you would want to state any restrictions on the domain. Okay. After you have reduced, you will look for vertical asymptotes and horizontal or end behavior equations. Thank you. If there is a hole, that's when there's a common factor, and we'll get to that later in the lesson. All right, the vertical asymptotes are what makes the denominator only equal to 0. Is that how it's stated on your green sheet? Can anybody look for me to say denominator equal to 0 for vertical asymptote? Okay, number 3 on the green sheet says it's a factor of the denominator but not a factor of the numerator, then there's a vertical asymptote, okay? End behavior is determined by the degree of the top and the bottom, and I'm going to do an example of that in a second. But before I do that, it says here x-intercepts. How do you take any fraction and make it equal to 0? When would a fraction equal 0? That's how I should phrase that question. I apologize. If the top is 0, right? If the top is 0, the fraction equals 0. So the x-intercepts occur whenever the numerator equals 0. And it says that number 4 on your green sheet. All right, the y-intercept, that's old school. We've been doing that all semester. When does this have a y-intercept? How do you find the y-intercept? X equals 0. You put in x equals 0 into the function. Okay? and that is number 5 on the green sheet. All right, the business about end behavior or horizontal asymptotes. If you have a degree of the numerator equal to 1, everybody okay? Degree is 1 here on the numerator. Degree of the denominator is what? Degree 2. So the numerator has a smaller degree than the denominator. Then it is considered bottom heavy. And if it's bottom heavy, if I put 1,000 into this real quick, I'd get 1,006 over 1,000,000 minus 3,000 plus 2. When I take that number on the top and divide by something that big, what kind of a number am I going to get? A super little number. So because of there being more degree of powers of x in the denominator, it's going to approach the line y equals 0. Could someone shut that for me? All right, because bottom heavy means you're going to get a really big number in the denominator. So the top, when you take the top and divide by the bottom, it's going to get really, really tiny and close to 0. Make sense? All right. Here, the degree of the numerator and denominator are equal. This one is degree 2 over 2. Everybody see that? Right? And be careful, they're not always in standard form. We know that. We got to be really careful. This one is in standard form. The definition says you'll have a horizontal asymptote at y equals leading coefficient over leading coefficient. What are the leading coefficients here? 2 and 1. So you would get the equation y equals 2. That's the shortcut. You could always divide it out. Does that sound really fun? Okay. Nobody wants to have to divide this out, and that's why we just do leading coefficient over leading coefficient. Because they're of equal degree, that's what we would get when we divided it out if we threw away any remainder. Unfortunately, when it's top heavy, this one is degree 2 over degree 1. Fortunately, last year, all you got to say was, there is no horizontal asymptote. Okay, you got to be done there. This year, you're going to have to go beyond that and find the end behavior it does approach, which could be a slanted line or oblique line. It could be a parabola. Okay, what you're going to have to do is divide this. Now, for this problem, we could use synthetic division because this is a linear term with just an x plus or minus something. The good news is you get to throw away the remainder, okay? Because out on the far ends, when you have really big numbers, the remainder just wouldn't matter anymore. And we'll talk more about that in a minute. All right, so this is the reference sheet you have. Here's my first example that you don't have, but if you go through this real quick with me, what's the restriction on the domain? X cannot equal what? And I'm not going to be picky unless it specifically says you have to put this in interval notation. I'm fine with you just writing x cannot equal 3. Deal? Okay. Vertical asymptote. On your sheet, that is any factor of the denominator. Okay, where would the denominator equal 0 here? This is where everybody gets confused. How can x not equal 3, but the vertical asymptote is at x equals 3? That's because the vertical asymptote is a boundary. It is not actually part of the graph. That's why we graph it as a dotted line. Does that sound familiar? Yeah. So when we graph this, we graph a dotted line at x equals 3, which they did right here. It is a boundary. The graph will never touch or cross that. So the fact that it's not part of the domain is the whole reason for the boundary there. All right, the second thing they want is a horizontal asymptote. So these are equal weight. Everybody good? So we do leading coefficient over leading coefficient, which would be 1 over 1. We get y equals 1, which is this red line going this way. To graph this then, you would type into y1 or whichever on your calculator parenthesis x plus 4, parenthesis divided by parenthesis x minus 3. Everybody's going to be really careful about parentheses, right? The whole top and the whole bottom have to be in parentheses. All right, this one you do have on your sheet. I want to go through domain again. This is really tiny. It's going to stretch the graph funny, but it's the only way I can make it bigger. It won't fit. Okay, still can't see it very well in my blind eyes, but it has an x plus 3 down here. So the restriction on the domain is that x cannot equal 3. Negative 3. I lied. Okay? That means there is a vertical asymptote at x equals negative 3. That's the line graphed right here for you. Okay? The end behavior, or the horizontal asymptote, this is degree 1 over degree 1. Everybody okay? Equal degree. So we do y equals leading coefficient over leading coefficient, which was 2 over 1, or y equals 2. That's this blue line. And on a test or quiz, you would label that y equals 2, and this one was x equals negative 3. All right, the other two things are the intercepts, the x and y intercepts. Does anybody remember how we determine x intercepts? Yes, the numerator is equal to 0. So if I do 2x minus 1 equals 0, I get 1/2. So you can't tell, but right over here at 1/2 0 is the x-intercept. The y-intercept is what? How do you find the y-intercept? Plug in 0. If we go back to the original, this was 0, this was 0, we would be left with negative 1 over 3. So the y-intercept down here, it is crossing at 0, negative 1/3, which are not very visible on that graph. All right, ready to try one? Okay. This one is in factored form, and it's going to be messier than the one that they just did in the notes for us, okay? First of all, domain restrictions you always want to do first, because when a question has a hole, that restriction is still part of the domain. In other words, you never want to cancel or reduce anything before you do the domain. So what are the restrictions on the domain? X and x minus 6 cannot equal 0. So x cannot equal 6 or 0. If we had to write this in interval notation, we'd have a big mess. Okay, you don't have to write an interval notation. There'd be u's in here, and okay. So what does that mean about our vertical asymptotes? There is one at x equals 6, and there is one at x equals 0. Those have to be equations because it's not a single point. It's a whole line that is either a boundary or something that the equation approaches. Those are both vertical, so it's a boundary. This is counting by 2's, so x equals 6 will be over here. X equals 0 is just the y-axis, but I'm going to label those as vertical asymptotes. Everybody all right? What do you want to do next? The horizontal or end behavior. This one is funky because it's already factored. What is the degree of the numerator? Degree 1. It only has an x. What's the degree of the denominator? 2. Everybody okay with that? We could FOIL it together if we needed to, but it is a degree 2. So that is considered bottom heavy, and what does that mean? I can't make a B. No, we don't have to divide it out unless it's top heavy. Bottom heavy means there's going to be really big numbers in the denominator, so it's going to approach 0. So the horizontal asymptote is at y equals 0, which is just the x-axis, yes? There we go. Y equals 0. Now, this one is a little funky because as soon as we get to the intercepts, how do we find the x-intercept? We set the top equal to 0, so we get what? Okay. -2, 0. How can that be possible? There's not a hole. It can cross the horizontal asymptote, okay? And this one does. So that was the 0 or the x-intercept. What about the y-intercept, guys? Put a 0 in. What's going to happen then? You get 2 over 0 times -6, which is 2 over 0, which is, it doesn't ever cross the y, which makes sense because wasn't the y-axis one of our intercepts, or our asymptotes, I mean, so, and it can't cross a vertical one, okay? So this is just none, which I just made a big mess of. Okay. The next thing you do is you type it in your calculator, making sure that you put extra parentheses around the top and the bottom. So it's parenthesis, x plus 2, parenthesis, divided by, parenthesis, x, another parenthesis, x minus 6, 2 close parentheses. Make sure you don't have any plots on up at the top because we did some regression stuff last week on the quiz, right? So make sure plot 1, plot 2, plot 3 are all turned off up at the top. And then start with a standard window, which is just zoom 6. Unless you mean you can't type. Okay, this is not a great graph or window for this graph. If you have an older calculator, it connects everything as it goes left to right on the graph, so it draws in those asymptotes, and it's kind of a hot mess. Okay? You can try, on mine, I could try to turn off the axes to see it a little better. It does help a tiny bit, but it's still not great. Does this graph end here and here? Okay, to check you could trace, and you want to trace close to those places. Now, this is at x is -0.42. If I get closer to that, like x is -0.01, it says I'm at 33. So does it stop? No. The same will go this way, okay? The other thing you can do is you can try zoom decimal. Often works really well, except it's a fairly small window. Zoom decimal does show a better picture, except that the whole right side is cut off. Okay, but it does, you can tell that it doesn't stop there. Zoom decimal, the reason it does that is because zoom decimal sets it to the number of pixels that your calculator has. So everybody's zoom decimal window is a little bit different depending on your type of calculator. All right, so we wound up. Where did it go out on the far left, guys? Did anybody trace out there? Yeah, it does become negative on the far left. If you trace out to like -8, it is negative, but it's tiny negative, right? It stays just below the x-axis. So let's draw a quick sketch, and that's all you need on a homework or a test or quiz. It does cross, but it stays just below. Sorry, mine is a little wavy. And then in between here, it's doing this. What was it doing out past here? Up here again, wasn't it? Okay, my graph is really bad, but does it cross out on the far right? Did anybody check? If you trace out to like 10, positive 10, it's still positive, right? It doesn't actually cross out in that direction. All right, I just want to talk about this example very quickly. You will notice this is degree 2 over degree 2. If you did leading coefficient over, you don't have this one, but you'd get y equals 2. Okay, so this has a horizontal asymptote at y equals 2, but you will notice that 4x squared plus 1 cannot equal 0. You get 4x squared equals negative 1, x squared equals negative 1/4, go to square root, and you get imaginary answers. There are no vertical asymptotes. This graph is doing this. Okay? That's the shape that it will be. I just show you that because it's possible that you will not have things that are hyperbola shaped. Okay? I'm going to move on to these. You don't have these either, but I just want to talk quickly about the fact that what is the very first thing, say, at the top of your green sheet? Okay. Before number 1, what does it say? Always factors. So this first one, you can take a 3 out here. And this helps you find that there is a 0 at negative 1/5. Okay. The x cannot be negative 5. There's a vertical asymptote at x equals negative 5. This is equal weight. Everybody okay? What happens, though, when you divide out leading coefficient by leading coefficient? Yeah, you get 15. Okay. If you put in a 0, you would get out 3/5. So there's a whole bunch of information about that graph. This is what's different about this one. It is top heavy. Everybody see that? Okay. This does not have a horizontal asymptote. If that's all it asked, you would say there is no horizontal asymptote. What's going to happen on a graph like this? You can do synthetic division, and you're going to be asked, because it's pre-calc, to find what's called the end behavior equation. In other words, what does this look like out on the far ends? You can do synthetic division. The 0 is negative 4. I bring this down. I multiply. I add. I multiply. I add. You get to throw this whole remainder away. What is this left? What is it approaching? Okay. What that means, and where's our vertical asymptote on this graph? X equals negative 4. What that means, let me just put an extra slide in here, is that if I zoom out on this graph, the whole graph, was it x minus 5? Okay. The whole graph is going to approach this line x minus 5, which is negative 5 with a positive 1 slope. But somewhere over here at, do you remember where the asymptote was? Was it 4 or negative 4? Okay. Over here at negative 4, it's going to do something different. So this is what the graph is doing. Okay. So if I zoom out far enough or squint really, all I'm going to see is this. Okay. But in here, there's one little goofiness going on. All right. When you are graphing these, you're going to find the domain. Then you're going to find the asymptotes and sketch them in. Then you're going to find the intercepts and sketch them in. And then you're going to graph it on your calculator. Step 4 is to just go to your calculator, okay? You don't have to put a bunch of points in. All right, these say find the domain. You don't have to do a sketch, so find the domain and the vertical and horizontal asymptotes. Can we go through these quickly? What's happening on number 1? Domain? Are there restrictions? If you subtract, you get negative 1. Use square root, and it's imaginary, so there are no restrictions. The domain is all real numbers. Does everyone understand that? You can square it and add 1, and it's always going to be a positive number, right? It's going to work. Okay, vertical asymptotes then? None, because that can never equal 0. Horizontal asymptotes or end behavior, what's going on? It is bottom heavy. Do I need to go over how we determined that it's bottom heavy? This is degree what on the top? 0 over degree 2. Okay. The denominator is greater degree. It's bottom heavy, so it will always approach y equals 0. All right. Question 2. What's going on here? X cannot equal negative 1. Good job. Domain restriction. X cannot equal -1. Perfect. X equals -1 is a vertical asymptote. Horizontal asymptote, degree 1 over degree 1, so it's equal weight, which says to y equals leading coefficient over leading coefficient, 2 over 1, or y equals 2. Didn't lose anybody yet? Okay, what's going on this one? Domain X cannot equal -1 or +2. So there are vertical asymptotes at X equals -1 or X equals 2. Now, as soon as you have two vertical asymptotes, there are going to be 3 parts to the graph. I have it here. I have a slide here. It's just not the very next one. When you have 2 vertical asymptotes, it means there's 3 different things going on the graph, okay? Now, the one in the middle isn't always going to be a U. Sometimes the one in the middle is like doing like a cubic shape. But there's 3 pieces, and you have to find them. If your calculator isn't showing them, you have to figure out where they are. All right, what about horizontal? If you FOIL the denominator together, it would be an x squared, so it is bottom heavy. So it approaches what? Y equals 0 is the horizontal asymptote. Okay, I didn't talk about zeros and x-intercepts. Are we okay on those, since we don't have to graph them anyway? All right, this is a top-heavy equation. Does everybody see that? Yes. Okay, in factored form, it looks like this. That means there's a vertical asymptote. Well, x cannot equal 3 is the domain restriction. There's a vertical asymptote at x equals 3. There is a 0 at 2, 0, and at 5, 0, because the numerator equals 0 there. Where's the y-intercept? Put a 0 in everywhere back in the original equation, and you end up with 10 over -3. Okay? So at 0, -10/3, or a little bit past -3, there's a 0. Now, there is no horizontal asymptote when it is top heavy. What you would do is have to divide this out. You could use, if you use the original function, what would go in the little box if I did synthetic division? Across the top would be, okay, bring down, multiply, add, but I get to throw all this away anyway. What is the end behavior equation? Okay. You don't get to stop anymore by saying there's no horizontal asymptote, I'm done. Okay? You have to keep going, because we're in pre-calc. You have to actually find what that end behavior is approaching. All right, so we just talked about, that one was actually an oblique asymptote, which means it's slanted. Slant asymptote, okay? We are going to also find ones that are not linear at all, and those are just going to be called end behavior equations. So if you just kind of lump them all together, you just call it the end behavior. What is it doing out on the far left and right? I just wanted to show you this one because, look here, this has a 2x cubed over an x squared. Does everyone see that that's top heavy? But can I do synthetic division on that one? If I have an x cubed over an x squared plus x minus 12, I would have to do long division. Yeah, there'd be a bunch of zeros here. Okay, and I'd multiply by 2x. This would give me 2x cubed plus 2x squared minus 24x. I would have to subtract, so I'd get a negative 2x squared plus 24x, get a minus 2, and then I'd have a remainder. They already did it. Okay, it came out this. What do you get to do with all that remainder, though? Throw it away. So they wound up with 2x minus 2. Okay, and the graph is down here at the bottom of the page on mine. Notice what's going on in the middle this time is more of a cubic shape, right? Okay. hole. Wake up. Some of you are sleeping. There's holes in the graph when you have a common factor in the numerator and the denominator. It can be canceled out, but because it existed at all, there's a hole there. Let me give you a really easy example. This is kind of off tomorrow's notes, I think. If this was the factor, this is really the equation y equals x minus 1. Does that make sense? But because the original equation had this here, x cannot equal -4, so there's a tiny little hole in that line. You would graph the line y equals x minus 1, except over here at -4 it would have a hole, because that was the original equation. All right, this is called a removable and non-removable discontinuity. We're not going to worry about it. We're just going to deal with this as a hole in the graph. This factors x minus 2x plus 2 over x minus 4x plus 2. So where's the hole? At x equals -2, there's a hole. To actually find the ordered pair, everybody listening? To find the ordered pair, what you do is you divide this out, and then you plug in the -2. So I'd get -2 minus 2 over -2 minus 4, which would be -4, 6, -6, so positive 2/3 is the actual ordered pair. On a test or quiz, as long as you tell me that it exists when x is -2, I will not make you find the ordered pair. I think it's helpful to find the ordered pair, but I'm not going to require it. All right, we're going to go on to this number 4 that you have. This is a tricky question because can we factor the denominator? The answer is yes, but not by just looking at it and not by grouping. This is a question you had to do last week on the quiz. How did you factor this when you had no information about it that would help us? You said all the factors of, and then you did what? You graphed it in your calculator, yes? Okay. I'm going to tell you that I graphed this in my calculator and it looked like this. Okay? It crossed at -3, -1, and +2. Can I just tell you that so we don't spend too long on this question? All right. So, how does the numerator factor? The top. Okay, x minus 7, x plus 3. Now, the bottom is a hot mess, but I just showed you how would it factor if this is what we got.
X plus 3, x plus 1, minus 2. That's what I said.
Okay, and I knew that only by graphing. This is the graph of the denominator only. All right, what do you notice right away? There's a hole at x equals -3. And we're going to find that ordered pair in a minute. But before we do that, you cannot get rid of any of the factors before you restrict the domain. Morgan, you with me? Okay. Before we cancel anything out, the domain cannot equal what 3 numbers? Okay. Don't ever throw away any of the restrictions on the domain. Okay, now here's another sentence. You got to listen to me very carefully. A graph cannot have both a hole and a vertical asymptote at the same place. It's got to have one or the other. Okay? It's got to have a vertical asymptote or a hole, one or the other. Can't have both. This graph, once we cross this out, there are no factors left, so it has a hole at -3. It would have a vertical asymptote if this had been an x plus 3 over an x plus 3 squared, so only one of them factored, then you would have a vertical asymptote there. I'm not going to give you that problem, okay? But what I'm saying is when it asks for the vertical asymptotes, you are only going to list what 2 asymptotes? X equals -1 and x equals +2. Okay, let's draw those on. and label them. X equals -1, x equals +2. End behavior. Anybody? Which is also called horizontal asymptote. Sorry. It is bottom heavy, so what do we get? Okay, so I'm going to draw that on real quick. And label it y equals 0. Okay, let's finish up with our whole, and then we'll talk about how to graph what's left. Once we have canceled this out, we put a -3 in to find the ordered pair of the whole. If I put a -3 in, I get -10 in the numerator. Down here, I get -3 plus 1 would be -2, and -3 minus 2 would be -5. So I get -10 over +10, which is -1. So the actual whole is at -3, -1. So that actually helps me because now I know that this piece of the graph is probably down here, huh? Okay. It's doing something in between here, and it's doing something over here. We'll talk more about this in a couple days, but if there's no squared factors anywhere, then it can't be on the same side here. I'll talk more about it later. All right, let's type it in our calculator. I always type in the original unfactored one because sometimes I catch a mistake that I've made when I factored or something. Wait a minute, this should have an asymptote here and it doesn't. All right, you guys type this in, please, because it's going to take me a half hour to do this. X squared minus 4x, what is the rest of it?
Minus 4x
minus 21 divided by quantity x cubed plus 2x squared minus 5x minus 6. Right, then I'm going to do a standard window. Yeah, sometimes Zoom Decimal will show you. So does this give me enough information to be able to draw a sketch that Hofbauer will be okay with? Now, I have my axes turned off. If I turn them back on. It's a little bit harder to tell what, we haven't found the intercepts either, by the way. Zoom Decimal, you can see the whole. Ooh, look right there, -3, -1, there's a missing pixel. It's not very exciting, really. Okay. Can you find the y-intercept just because that will help me do the little UE in here a little bit better? The y-intercept, guys? How do you find the y-intercept? Put a 0, so you get -21 on top and what on the bottom? -21 over -6. It's 3.5 or 7 halves. You can give me a decimal, I don't care. So it's up here at 3.5, so it's doing some loop-de-loopy thingy up here. All right, does it have x-intercepts, guys? It does have an x-intercept out at what? Where's the x-intercept? Hey, the x-intercept is at 7, 0. So, whoops, that's not what I wrote. So it crosses out here at 7. So it actually crosses that horizontal asymptote. It actually crosses. If I go back to my graph, if I do trace 7, or just kidding, it's at, yep. Okay, if I go to 7, I'm at 0, but if I go past 7, notice it is positive. Barely. It's very small. It's going to get tiny little small decimals. All right. You're the first class that even got to this last question. Let's see how fast we can get through this. What's going on? As school clock is off, apparently, because it's not going to ring for 3 more minutes. I'm telling you right now. So we got time to get started. X plus 3, x minus 2, right? X plus 1. Are there any holes? Okay, x cannot equal negative 1. Vertical asymptote at x equals negative 1. Da, 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 da. Oh, that's beautiful. Then what? Top heavy. What does top heavy mean?
You gotta find it.
We got to divide. Can we do synthetic division, though?
Yeah.
1, 1, negative 6. It's really short. Bring down the 1, multiply. You get 0.
0, negative
0, negative 6. We get to throw this away anyway. So it is approaching what?
y equals x.
Y equals x, which is this line right here. Okay? Intercepts. X intercepts.
Negative 3.
Negative 3 and positive 2. Negative 3, positive 2. Y-intercept? Yeah, y-intercept is when you put in a 0, so you get negative 6 over 1 or negative 6 down here somewhere. Okay, that tells me that this side is doing this shape, and this side is doing this shape, and that's it. It approaches this line out on the far ends. It just has one goofy thing in the middle.